Okay, in this video we're going to discuss and learn the properties of logarithms. And by the end of this video, you should be able to, 1, condense, and 2, expand logarithmic expressions using the properties of logarithms. And first, let's go over one of the three major properties. The first property that we have is called the product property, where it states that if we have log base b, the product of two or more terms, then we can split apart each of those terms and give them their own log. So we could say log base b of m plus log base b of n. And this can go back and forth from the left to the right and from the right to the left. And that's where the condensing and the expand. If it asks you to expand, we'll be expanding from the left to the right side. If we're going to condense, we're going to take something that is in the form of the right side and condense it back to the left side. And we've got a couple examples for this. So the first example is let's condense. So our example here is log 25 plus log 4. And just a reminder that the only way these properties work is that they have to have the same exact base. And if we don't have a base here, remember that is an automatic base 10. But because the plus sign is in between the logs, I know that I can put this back together as one log and multiply the 25 times the 4. Or, in other words, say that this condenses down to log of 100. And a second example, we can do this with algebra. Log base 4 of 2x plus log base 4 of 4x squared. And you should notice that the 2x is in place of where the m is at, and that the 4x squared is in the place of the n. Because of the plus sign, we can use the product property and put this back together and go log base 4 of 2x times 4x squared. Now this does require us to use some exponent rules and simplifying that we learned back in Algebra 1. And that 2x times 4x squared would simplify to 8x to the third. So this would condense down to log base 4 of 8x to the third. And that is the use of the product property. The next property that we have, before we go to the next property, let's go to the expanding examples. So expanding, we're going to have one log, and we're going to split this apart to where there are multiple logs written. A little bit more difficult examples, but you need to think of what's a way that we know that multiplies to give us 45. Well, the first two numbers that pop into my head, and most likely pop into your head, is 9 and 5. Since 9 times 5 is 45, and there is a product between those two numbers, the product property states that we can expand this apart and give the 9 and the 5 its own log, to where log base 7 of 45 is equivalent to log base 7 of 9 plus log base 7 of 5, and there is our expanded answer. For another example, what about algebra? When you look at log base 2 of 5x, you must remember that the 5 and the x is technically a product, where we can think of this as log base 2 of 5 times x, and then the 5 and the x can get their own logs based on the product property, which is equivalent to log base 2 of 5 plus log base 2 of x for our expanded answer. Alright, so that's all about the product property. Now let's move on to that next property, the quotient property. So quotient would mean division, and if we have a log of in other words, a fraction, we can split that fraction apart and go log base b of m minus log base b of n. To make it simple for you, let's think of it in this terms. Let's go log of the top minus log of the bottom. It will always be top minus bottom for you. And like so, we're going to go in the condensing direction. So condensing would mean we're going to take something that's in the form of the right side and make it look like the left side. We have log base 3 of 24 minus log base 3 of 8. And as I said just a few seconds ago, we always want to go log of the top minus log of the bottom. If we go the left to the right direction, the top would be the left side, and the bottom would be the right side. So now this condenses down to log base 3 of 24 over 8. But we know 24 over 8 also simplifies. So this would condense completely down to log base 3 of 3. Another example, log base 4 of x to the 9th minus log base 4 of x squared. Going left to right always, the left would be the top of the fraction, and the bottom would be the right side. So now we have log base 4 of x to the ninth over x squared. Using our exponent rules, since we have division, we get to subtract our exponents, and we'll go top minus bottom. Since 9 minus 2 is 7, this condenses down completely to log base 4 of x to the 7th power. And that's condensing using the quotient property. How do we expand? Expanding, in my opinion, is usually the easier method. But I'm going to start off with probably the most difficult example of the expanding, because we have just a number, log base 8 of 4. We don't see that fraction there, but it's not too difficult to think of an equivalent fraction to 4, like, what about 8 over 2? Since 8 over 2 is technically 4 simplified, but you can see the fraction. Now we can use the quotient property and go log of the top minus log of the bottom to expand this out into log base 8 of 8 minus log base 8 of 2 for our completely expanded answer. How about with a little bit of algebra? Well, there we see the actual fraction, log of m over 7, and if you can just remember, log of the top minus log of the bottom, we can get our completely expanded answer, and we will be finished with that. So the quotient property is, more times than not, a lot easier to recognize when it comes to expanding. The third and final property is called the power property. That if we have log base b of m raised to the n power, we can take that exponent and essentially factor it out front to have n times log base b of m. So when I ask to expand would be going from the left to right direction. If you're asked to condense, you'll be going from the right to the left direction. So condense. We have 5 times log base 4 of 2. Well, the question then becomes, where did that 5 come from? Well, originally, the 5 used to be the exponent, so we're going to put that back. Now we have log base 4 of 2 to the 5th power, but we do know what 2 to the 5th power is, and by typing that in, we can find that this condenses to log base 4 of 32. Another condensing example. Sometimes you're going to see fractions out in front of the log, but if you can remember that the number multiplied in front of the log used to be an exponent, we put it back as an exponent. Now it's log 8 to the 1/3 power, and you can use your calculator to figure out what is 8 to the 1/3 power. Well, that's just 2. So this condenses to log of 2. And now for some expanding examples. We have log base 2 of 8 to the 7th power, but by the power property, we are allowed to take that exponent and factor it out front, and this would expand to 7 times the log base 2 of 8. If we have log base 7 of square root of w. Now, the only way that we can use the power property with radicals is that we have to know what their equivalent form is in rational form. So here's an example. The square root of x. Well, all radicals have what we call an index, and that index is typically, or will always be written just inside the tail of that root. If you don't see it for a square root, that means that the index is a 2, and that the exponent of the radicand, the part underneath the radical, is a 1. This is equivalent into its rational exponent form of 1 over 2 power. So the index will always be the denominator of the fraction as its rational exponent form. So using that, then I could say, well, log base 7 of the square root of w, well, that's equivalent to log base 7 of w to the 1/2 power. And now I'm allowed to use that power property by taking the 1/2 power, putting it out front, and this would completely expand into 1/2 times log base 7 of w. Now those are some quick isolated examples of where we learn how to condense and expand using those properties, but here's the real question that we have. Can we condense or maybe expand logarithmic expressions if we can apply them properties, maybe multiple properties, or apply more than one of those properties in the one example? And that's where these problems do tend to get a little more difficult. So let's go through some examples. If you want to be successful at these problems, you need to go all the way back to when we first learned our order of operations with PEMDAS. More importantly, with condensing these problems. We learned that in the order of operations that you must always start with the parentheses, inside the parentheses, and go right down the line with the rest of the order of operations using exponents, multiplication or division from left to right, and addition or subtraction from left to right. But for condensing, with the order of operations, we have exponents. If we're inside these parentheses or we don't have parentheses, we always want to look for exponents. Now there's a property that involves the exponents. That's the power property. So you always want to look to use the power property first. And then afterwards, since we're going to be condensing, we're going to be putting things back together. We look for addition and or subtraction from left to right. Now those properties that included addition and subtraction were the product property and the quotient property. So we want to use those properties, whatever comes first, from left to right, just like we were taught in the order of operations. So how does that work? Here's our first example. We have log base 3 of 4 plus log base 3 of y plus 1/2 times log base 3 of 49. Now we see that we don't have any parentheses, so the next thing is, as I said, look for exponents or the property that used exponents. Well, then we have an example here. Well, 1/2 used to be an exponent, so let's put that back as the exponent of the 49. So now we have log base 3 of 4 plus log base 3 of y plus log base 3 of 49 to the 1/2 power. So now we got everything put together in lots of additions. Go from left to right. Let's start with the first addition sign. That says, well, we can take 4 and the y and multiply it together because of the product property. So this would simplify to log base 3 of 4 times y. And then afterwards, I'm going to go ahead and simplify that 49 to the 1/2 power. Well, this turns into log base 3 of 7. And then what I hope you notice is that, well, I got another plus sign between the logs. This tells me to use the product property once again. What am I taking the product between? It's the 4y that we just made with our first log and the 7 that we got after the 49 to the 1/2 power. Multiply those two together, and this would completely condense down to log base 3, 28y for our final answer. So you really do need to use that order of operations idea to be 100% successful at condensing these examples. All right, another example. 1/3 times the sum of log base 5 of 8 and log base 5 of 27 minus log base 5 of 3. Well, this time we do have some parentheses, so let's focus on the operations that occur inside of there. That operation is a plus sign, so that tells me we need to apply the product property, the product between 8 and 27. And when we condense that down, we still have the 1/3 out in front, but 8 and 27 would make 216 when you multiply. However, we still have the minus log base 5 of 3. So we take care of the parentheses, go right back down the line of the order of operations. Were there any numbers in there that used to be exponents? You should be saying, well, the 1/3 used to be an exponent based on the power property, so we need to put it back. So therefore, log base 5 of 216 to the 1/3 minus log base 5 of 3. And then, well, there's a minus sign there. That's the only symbol that we have left, and that's the quotient property. And going from left to right, we got the number on the left would be the top of the fraction, and the number on the right would be the bottom of the fraction. So therefore, 216 to the 1/3 is really 6, and we have 3 on the bottom, and we know 6 divided by 3 is 2. And we get a final answer of, or a condensed answer of log base 5 of 2. So now let's try some expanding problems. What if we have everything written in one log? Can we expand it out to where there are multiple logs written? Now, what I want you to see here, between the x, the y, and the z to the 4th, there are 2 multiplication signs. And we talked about the product property, but we really only teach it with the product between 2 terms. But here we have 3 different terms that we're multiplying. We've got x, y, and z. As long as there's products between them or multiplication between them, each one of those terms can get its own individual log. So x, y, and z to the 4th each get their own log. You can put a plus sign between them. After you apply the property there, I want you to look at each log that we have individually and ask yourself the question, could I apply any more properties of logarithms? I don't see any fractions on the first one, don't see any fractions in the second one, nothing in the right one as far as fractions. However, we do have an exponent, so that power property allows you to take that 4 and put it out front. And we get a completely expanded answer of log base 6 of x plus log base 6 of y plus 4 log base 6 of z. Again, most students that I've had in the past seem to like the expanding examples much more than the condensing ones. All right, another expanding. How about log base 2 of y divided by z to the 5th all raised to the 2nd power? Now, again, if you think about the power, or the order of operations here, you would ask, well, could I take that 2 because it's an exponent and put it out front? However, yes, you could do that. I think you're going to be much more successful applying your rules of exponents first. And our rule of exponents that we had, if you had something inside of a parenthesis raised to a power, the power to a power property, anything and everything in there, you get to multiply their exponents by the exponent on the outside. So that means y on the inside has an exponent of 1. 1 times 2 is 2. The exponent on the bottom, the 5. 5 times 2, we get 10. So there we took care of that exponent. Now the reason why I did this is that well, I've got this fraction, and I know I've got this quotient property where I can take log of the top minus log of the bottom. So now we have log base 2 of y to the 2nd power minus log base 2 of z to the 10th power. But you, again, should notice in both of these logs they have exponents. So for every exponent that you have, you can use the power property and put it out front. So that would give you 2 log base 2 of y in the first log. And then on the second one, well, there's an exponent there as well, that's a 10. So in front of that log, we can say minus 10 log 2 of z for our completely expanded answer. All right, one final example that I have for you. Let's do one with radicals. So this radical, we have log base 3 of the 4th root of m to the 5th n squared. Now the radical has lots of things going on here, but I don't really want you to look at all of this right now. I want you to think of that as a completely big variable, almost like it's a giant x in this case. And if you do that, well, this part could be raised to an exponent. That exponent could just be a 1. So when you turn it into its rational exponent form, that is log base 3 of m to the 5th n squared, all raised to the 1/4 power. And apply some more rules of exponents. That we have powers raised to a power. So you can take that exponent and multiply it by both. This gives us log base 3 of m to the 5/4 power and n to the 1/2 power, getting 1/2 from 2 times the 4th. But as long as we got rid of those radicals, we got rid of the parentheses, we should notice that there is a product right between these two terms, which tells me that I can give each one of those terms its own log with the addition sign, the product property. And then each of those terms have exponents, so we can take the exponents, doesn't matter if it's a fraction or not, but we can distribute it out front. And the 1/2 can also come out as front as well. And there it is, there's your completely expanded properties. So I hope you find this video helpful on the properties of logarithms and how to use those properties of logarithms to either condense or expand logarithmic expressions.